Welcome to phase shifts and vertical shifts. So in the last podcast, we saw how to transform the graphs by changing the amplitude and stretching our graph or shrinking our graph vertically, changing the period to shrink and stretch our graph horizontally. Now we're going to learn how to translate our graph, right? So a phase shift is just a horizontal translation. Right? So if your b, remember that number that the coefficient in front of x that we use to find the period, if that's factored out away from the x, right? So it's been factored out. It's not part of the x anymore. It's in front of the x. It's it's in front of the parentheses, right? Then our phase shift is just the value in the parentheses, but just like all of our functions, when we subtract, we have x minus, means we're going to shift to the right. If we have x plus, we're going to shift to the left. So my little example here, y equals AF, the F just means sine or cosine, of B, right? B's already been factored out, x plus C, so that would represent our phase shift. In this little example here, our phase shift would be C units to the left. Right? I'm shifting C units to the left. Right? But what if B is not factored out? For example, we have y equals cosine 2x plus pi. B is not factored out. It's inside the parentheses there. We have one of two choices. I like choice number one, which is if B is not 1, just factor out B. Right? So then what's added to x is your phase shift. So we have y equals cosine 2x plus pi. If I factor the 2 out, I'm going to divide everything by 2. So we're going to divide 2x by 2, and we're going to divide pi by 2. Right? So pi divided by 2 would be pi halves. So our phase shift, you can either write it as negative pi halves or left pi halves units. Either is fine. Right? We can see it right there by just identifying what's added to x. And if it's positive, we know it should be a negative value. It means left. And if it's negative, it's a positive value. It means right. So another way, if you don't like that way, I like that way because I had to identify b anyway for the period. So I just figured I'll just factor it out. Makes it really easy to find my b. And then I've got my b for my period, and I've got my phase shift. But if you don't like that way, method number 2, you can take c, the value that's added to the x expression, and divide that by b. That'll also give you your phase shift. There's no need to do that if b, however, if b is in the if b is in the parentheses. So there's really no need to do it if b is not in the parentheses anymore, because you already know your phase shift if it's been factored out. So taking c and dividing by b, this is only if b is still in the parentheses. Don't do this if it's been factored out. Right? Otherwise, you'd be factoring out twice. Another method you could do, if you don't like either of those two, is you could set the quantity inside the parentheses equal to 0 and solve for the variable. So if we have 2x plus pi is equal to 0, right? So this is what was inside the parentheses. We set that equal to 0. Right? So we subtract pi from both sides, divide by 2, pi equals negative pi halves. So we're shifting pi halves to the left. Right, we get the same answer. So, and that you can always do regardless of whether or not b is factored out. Right? Don't do c divided by b if b is factored out. If b is already factored out, you're not going to factor out again. But you could use the third method anytime. So, for instance, if I take x plus c and I set that equal to 0, I get x equals negative c. Right? So that's negative c or c units to the left. Right? So just a little reminder on direction. When we're shifting horizontally. I don't like spinning ball of death. I don't know if you see spinning ball of death when I see it. Whoops. Well, we went 2 pages. Come on. Come on. All right. So we have an example. So this could be y equals a sine bx minus c, or y equals a cos b x minus c. Right? You're going, if your c value So your C value will shift you right and left. It's a phase, called a phase shift. Right? If C is greater than 0, it shifts to the left. So if we have x plus C, that means we're shifting to the left. If C is less than 0, in other words, we have x minus C, we're shifting to the right. And if b is not 1, factor out b. So for instance, here's an example. Y equals sine 3x plus 9. Our phase shift is not 9 because the b is already in there. So we can factor the b out, and then we have, if we divide 3x by 3, we get x. We divide 9 by 3, we get 3. Our phase shift is left 3. Or alternatively, you can do, so phase shift, you can do, this is the C, right, and this is the B. Right, so you can also do 9 divided by 3, which is 3. But like I said, you have to identify your B for your period anyway. I kind of just like the first method, but I figured I would show that to you. Or you can also do, let me use a different color here, 3x plus 9 equal to 0. So 3x is negative 9, x is negative 3. Right? So either way, either way, you end up with the right answer so long as you correctly identify that C was negative 9. If you correctly identify C as being negative 9, so you have to remember that this is really minus a negative 9. So that's extra thinking for me. So sometimes I don't always use that. I don't generally use that method. So we have to remember that that's minus a negative. So if you can remember that, then you can use B divided by C, right? Or excuse me, C divided by B. And actually, let me write that down. So here's another way to get our phase shift is to take C divided by negative. I just want to make a negative in here. I don't know what it is. I think I'm worried about running out of space because it ended my tape on the last one. This is the second time I've done this one. So phase shift is C divided by B, but be careful on your C, as you just saw. Or you can just factor it out, and then just remember, you see the plus, it means you're going left. Right? So it's a left 3. Or you can set it equal to 0 and find it that way. You know? So either way, though, you're going to get the same answer so long as you're careful. All right, so let's identify some phase shifts now that we've talked about them enough. All right, so here, what's the phase shift for the following functions? Right? And so you can either identify it as a direction or in terms of the sign. All right, so here, my phase shift. B is already factored out, so I don't have to worry about it. B, by the way, is 1. The phase, because you don't see anything there. You don't see a coefficient. So the phase shift here is 3. Right? I'm going 3 to the right. So you can say phase. I don't know if you just saw the morning that tells me I'm almost full. Let's see if we can finish. So phase shift is 3, or I could say shifts 3 to the right. Shift 3 to the right. Okay? Here, I need to factor out B. B is equal to 2. Right, so we'll factor it out. So h of x equals cosine 2x plus 2. Right? I just divide 2x. Right, so 2x divided by 2 is x. And 4 divided by 2 is 2. Just divide both of those by 2. All right, and so now my phase shift, I see a plus, so that's going to be negative 2, or you can say shift 3 to the left. 2 to the left. I'm looking at the one next to it. I'm looking at number 1, shift 2 to the left. All right, so here we already have B is already factored out. B is 1. All right, so our phase shift I say an E there, phase shift is -4, or we could say we shift 4 to the left. Last one here, we need to factor out. All right, so our B is 2/3. I don't want to write green. It's right next to that one. B equals 2/3. All right, so we're going to divide everything by 2/3. Right, so we have h of x equals sine 2/3, dividing x by 2/3 x by 2/3 is no problem. That's going to be x. Right, so dividing 4 by 2/3 is the same as 4 times 3/2, the reciprocal. All right, so that would be 12 over 6, or excuse me, 12 over 2, or 6. I'm already thinking 6. All right, so that's plus 6. All right, so we can say that our phase shift is -6, or shift 6 to the left. You had 3 that were left and 1 that was right. Right? That's all there is to phase shift, and there's nothing more. The last kind of transformation is a vertical transformation. Even easier, right? So vertical transformation, we just have a value added to our function. It is not attached to the sine or cosine. It is added on. It could be added on in front, like y equals d plus a sine bx minus c, y equals d plus a cosine bx minus c, or it could be added in the back. Y equals a sine bx minus c plus d, y equals a cosine bx minus c plus d. All right, so that d is our vertical shift, and it is what it is. So it's up if it's positive. So if d is greater than 0, you shift the graph up d units. If d is less than 0, you shift the graph down d units. That's all there is to vertical shifts. They are pretty easy. They're just like all of our other graphs. Matter of fact, all of our horizontal and vertical transformations are exactly the same. Only sine and cosine have period and amplitude, but the rest is the same. So when we have a vertical transformation, a new horizontal axis known as the midline becomes the reference line or equilibrium point about which the graph oscillates. Normally, sine and cosine oscillate around y equals 0, the x-axis, right? So midline is a vertical shift. There's no vertical shift. The midline is y equals 0. If there's a vertical shift, your midline is whatever the vertical shift is. Right? So the midline is the line the sine or cosine graph is oscillating about. I like to graph that line, right, because it helps me make sure that my points are in the right place, right? It kind of gives me I've got an easy place to put my new intercepts, if you will. I can just use that midline value to help me graph properly. And actually, if that sounds a little confusing on how you use the midline to graph, do not worry, because I will show you in later videos when we're graphing. But just know that whatever your midline is exactly the same as your vertical shift. In the next podcast, I'm going to talk more about vertical shifts and combining all of our transformations together, and then we'll be graphing. All right, so bye for now.